Right, so here are some of the solutions to the acceleration lecture notes things, okay? So for the first one, if we define sort of average acceleration as the change in velocity over the change in time, so here that's the initial, or the final velocity minus the initial over the change in time. So here it says if I'm driving a car originally traveling at 8 meters per second, and you accelerate to plus 12 meters per second. Okay, so you could do the math, but please make sure you keep sort of a foot in normal person, sort of like reality of what the math represents, so that if you are, if your velocity is changing, okay, so mathematically we get, what, plus 2 meters per second per second? Okay, and that makes sense because each second your velocity is changing by plus 2 meters per second. So after 1 second it would be to plus 10 meters per second. So after 2 it would be to plus 12 meters per second. So hopefully that sort of makes sense. Okay, so for 2, same situation. So the change in velocity, the final velocity is 0. Okay, minus the initial velocity of 1,240 meters per second. Now, how can we represent the direction? Because right now it says direction east. Okay, so putting that east, let's just put it as positive, but let's make sure that we define positive as east. What direction would negative be? West. Okay, so if you're going at plus or 1,240 meters per second to the east, and you come to a rest, what must your acceleration be over that time? It's got to be westward, because that's the only way that your velocity is going to change sort of not in the eastward direction, if that makes sense. So, oops, sorry, this is 15 seconds. So you can do the math. It should be negative, whatever I told you the answer was. You can do that. Okay, so conceptually, let's look at here. If I braked a bit harder, it took me less time to stop. What would that do to my average acceleration? Well, I would say that an important sort of way to describe that is, let's say that the magnitude of the average acceleration is greater, but make sure that you don't say like it's less just because it's negative. The magnitude is going to be greater, okay? So you could say more westward because that change of velocity is happening over a smaller period of time. So meaning the change of velocity is the same, but the change in time is really, really small, which leads to a much bigger average acceleration, if that makes sense. All right. Number 4, the car is traveling on a straight road with a negative velocity and a positive acceleration. That means let's say that you had a negative 40 meters per second velocity with a plus 10 meter per second if it helps you to put in values, acceleration. Well, that means that each second your velocity is changing by this amount. So meaning after 1 second your velocity would be negative 30 meters per second. After 2 seconds, negative 20. So that means your speed is doing what? You're slowing down. Okay, for number 5, the only trick here is it's saying the acceleration. So again, we're using the change in velocity over the change in time. All right, the change in time is pretty clear that it is 0.10 seconds. And now the change in velocity, don't go for the trick that don't go blindly just plugging numbers in, okay? Because it's going towards the catcher initially at 35 meters per second, but then what happens afterwards? Going that way at 52 meters per second, and that's me hitting the ball, right? So make sure the final velocity, what must you represent here? If you're describing velocity and accelerations, which are all vectors, let's call this minus. So again, let's define what the direction is. Plus equals towards catcher, minus equals towards pitcher, okay? Make sure that you include that, okay? So I get minus 52 meters per second minus plus 35 meters per second, and whatever that comes out to. And again, keep a foot in sort of like conceptual land. Think about the acceleration should be towards the pitcher. It should be negative. Okay, hope that helps. Bye.